The final images did not look like a goodbye. They looked like a warning from another world, a golden sphere wrapped in haze, hiding its surface beneath a thick atmosphere of nitrogen and methane. No sharp continents, no blue oceans, no familiar clouds drifting over a living planet, just an orange veil, glowing softly in the weak sunlight nearly 1 billion miles from Earth. This was Titan, Saturn's largest moon, and for most of human history it was almost invisible to us. Not because it was too small. Titan is larger than Mercury. Not because it was unimportant. It is one of the most scientifically extraordinary worlds ever discovered. But because Titan does not reveal itself easily. It hides. Its atmosphere is thicker than Earth's. Its surface is buried under layers of organic haze. Its lakes are not made of water, but liquid methane and ethane. Its rivers carve channels through frozen ground. Its weather is strange, slow, and alien. And beneath its icy crust, there may be a hidden ocean of liquid water. For decades, Titan was only a blurred orange dot in telescope images. A mysterious moon orbiting Saturn in silence, too distant and too clouded to understand. But then, a spacecraft arrived, and slowly, frame by frame, radar pass by radar pass, Titan began to open. The mission was Cassini, and near the end of its life, after more than a decade orbiting Saturn, Cassini took one final close look at Titan, not just as a moon, not just as a target, but as the world that would decide the spacecraft's final fate, because Titan did not only reveal secrets, Titan helped send Cassini to its death. Cassini arrived at Saturn in 2004, carrying with it one of the most ambitious scientific packages ever sent to the outer solar system. It was built to study Saturn, its rings, its magnetosphere, and its moons. But Titan was always one of the central mysteries. Before Cassini, scientists already knew Titan had a dense atmosphere. That alone made it unusual. Most moons are bare, airless, cratered worlds. Our own moon has almost no atmosphere. Europa has only a faint exosphere. Ganymede and Callisto are largely exposed to space. But Titan was different. Titan had air, not breathable air, not warm air, but a real atmosphere, mostly nitrogen, with methane and complex organic molecules mixed within it. In some ways, Titan's atmosphere made it feel almost Earth-like. It had clouds, weather, winds, seasons, a climate system, but the surface was hidden. Visible light could not easily penetrate the haze. From space, Titan looked like a smooth orange ball, its real landscape buried beneath a chemical fog. To see through it, Cassini had to use radar and infrared instruments. It had to look at Titan in wavelengths the human eye cannot see, and when it did, the results were stunning. Titan was not a dead ball of ice. It had landscapes, vast dunes stretching across its equatorial regions, dark plains, mountain-like ridges, channels that looked like river valleys, polar lakes, possible seas. But the strangest part was what those lakes were made of. On Earth, rain falls as water, rivers carry water, lakes hold water, the entire surface system depends on it. On Titan, the temperature is around -179 degrees Celsius, cold enough that water behaves like rock. It is frozen solid, forming part of the crust. But methane and ethane, which are gases on Earth, can exist there as liquids, so Titan has a methane cycle. Methane evaporates, clouds form, rain falls, rivers flow, lakes fill, storms reshape the landscape. It is the only world besides Earth where stable liquid is known to exist on the surface. But it is not water flowing under a blue sky. It is liquid methane moving across frozen terrain beneath a poisonous orange atmosphere. That is why Titan is so haunting. It looks familiar in structure, but alien in substance. It has rivers, but not water. It has rain, but not rain we could touch. It has seas, but seas that would freeze human skin instantly and boil away under Earth-like conditions. Titan is not Earth, but it is the closest thing to a twisted reflection of Earth that we have ever found. The first real encounter with Titan's surface came not from Cassini alone, but from the Huygens probe. Carried by Cassini across the solar system, Huygens separated from the main spacecraft and descended into Titan's atmosphere in January 2005. For the first time in history, a human-made object entered the skies of an outer solar system moon. The descent was slow, almost dreamlike. Huygens fell through the haze, measuring the atmosphere, taking images, recording winds, temperatures, and chemistry. As it dropped lower, the hidden surface finally appeared. The images were unlike anything scientists had expected. There were dark channels branching across brighter terrain, like drainage networks carved by flowing liquid. There were rounded pebbles scattered near the landing site, shaped as if they had been transported by streams. There were signs that liquid had once flowed there, perhaps recently, in geological terms. When Huygens touched down, it landed on a surface that was not hard rock in the earthly sense. The ground behaved more like damp sand or clay, made of icy grains and organic material. It was cold, strange, and dimly lit. The sun was far away. Saturn was hidden behind haze. The world looked ancient, quiet, and deeply alien. Huygens survived only for a short time on the surface, but in that brief window it transformed Titan from a mysterious orange moon into a real place, a world with terrain, a world with weather, a world where chemistry and geology were working together in ways we still do not fully understand. But Huygens only saw one location, one tiny patch of Titan. Cassini's job was to reveal the rest. Over the next 13 years, Cassini returned to Titan again and again. Each flyby changed the map. Radar images sliced through the haze and revealed coastlines near the poles. Dark lakes appeared in the north. Some were small, scattered across the landscape like black glass. Others were enormous. Kraken Mare, Ligeia Mare, and Punga Mare became some of the most important features ever discovered beyond Earth. These were not hypothetical oceans, they were real bodies of liquid on another world. Radar reflections showed smooth surfaces, consistent with liquid hydrocarbon seas. Some regions appeared so calm they reflected radar-like mirrors. Others suggested shorelines, islands, channels, and possible changes over time. Titan was not frozen in place. It was active, but slowly. Everything on Titan happens under different rules. Methane rain does not fall the way water rain falls on Earth. Seasons last for years because Saturn takes nearly 30 Earth years to orbit the Sun. Weather patterns change over long cycles. Storms can be rare but powerful when they happen. Cassini watched Titan through seasonal transition. It saw cloud systems appear and vanish. It detected changes near lakes and seas. It observed atmospheric patterns shifting as sunlight moved from one hemisphere to another. The moon was breathing with the seasons, slowly, silently, but undeniably. And still, the most mysterious thing remained hidden beneath the surface. Titan is not only strange on the outside, it may be even stranger within. Gravity measurements and orbital behavior suggest that Titan likely has a subsurface ocean beneath its icy crust. This ocean would not be methane. It would be liquid water, possibly mixed with ammonia or salts, buried under layers of ice. That possibility changes the meaning of Titan completely. On the surface, Titan is a world of methane lakes and organic chemistry. Below the surface, it may contain a water ocean, one of the key environments scientists consider when thinking about habitability. That does not mean life exists there, but it means Titan has ingredients that matter: complex organic molecules, energy sources, surface liquids, and possibly a hidden water layer. It is a natural laboratory for chemistry that may resemble processes that occurred on early Earth before life emerged. This is why Titan is so important. It does not simply show us what another moon can be, it may show us what prebiotic chemistry looks like on a planetary scale. The haze itself is part of the mystery. Sunlight and charged particles break apart methane and nitrogen in Titan's atmosphere, allowing complex hydrocarbons and nitriles to form. These molecules combine into larger organic particles, creating the thick orange smog that hides the moon from view. Eventually, some of that material falls onto the surface like a slow chemical snowfall. Over millions of years, Titan's surface has been coated in organic material. In a strange way, Titan is not just a moon. It is a chemistry experiment the size of a planet. And Cassini spent 13 years watching that experiment unfold from orbit around Saturn. But the final images from Titan carried a different weight. By 2017, Cassini was running out of fuel. The spacecraft had performed brilliantly for far longer than expected, but its mission could not continue forever. Eventually, NASA had to make a decision. They could not leave Cassini drifting uncontrolled through the Saturn system. The reason was contamination. Two of Saturn's moons, Enceladus and Titan, had become too important. Both were considered worlds of astrobiological interest. Enceladus had an ocean and geysers spraying water into space. Titan had organic chemistry and possible internal water. If Cassini were left uncontrolled, there was a very small chance it could someday crash into one of these moons. That risk was unacceptable, so mission planners chose a dramatic ending. They would use Titan one last time. On April 22, 2017, Cassini flew past Titan in what became known as the mission's final close encounter with the moon. This flyby was not only scientific, it was gravitational. Titan's gravity would bend Cassini's orbit, changing its path forever and sending it into a new series of daring passes between Saturn and its rings. These final orbits were called the grand finale. Titan gave Cassini the push, a farewell from the moon that had revealed so much, redirecting the spacecraft toward its final descent into Saturn. That is what makes the final Titan images so haunting. They were not just observations, they were the last close views before Cassini entered the final chapter of its life. A spacecraft looked back at one of the most mysterious worlds in the solar system, collected what it could, and then allowed that world's gravity to send it toward destruction. It was science, but it felt almost poetic. In those final observations, Titan still refused to show itself easily. The images showed the familiar haze, the soft orange glow, the hidden surface beneath. But by then, scientists knew what was underneath that veil. They knew that below the atmosphere were dunes made of organic particles. They knew there were methane lakes near the poles. They knew that rivers had carved channels. They knew that Titan's surface had been shaped by wind, weather, liquid, and time. The image looked simple, but the knowledge behind it was enormous. That is the power of Titan. Every plain-looking view hides a world of complexity. A smooth orange disk is not just a disk. It is an atmosphere thicker than Earth's. It is a methane climate system. It is organic chemistry. It is a frozen crust. It is possible subsurface water. It is a moon that behaves more like a planet. When Cassini looked at Titan for the last time, it was not looking at an object it had fully solved. It was looking at a mystery it had only begun to understand. And that may be the most important part. Cassini did not end the Titan mystery. It opened it. One of the most bizarre discoveries Cassini made was how Earth-like Titan's landscapes can appear when seen through radar. The dunes near Titan's equator stretch for hundreds of kilometers. They are shaped by winds, much like dunes in Earth's deserts, but the material is completely different. Instead of silicate sand, Titan's dunes are likely made from organic particles, hydrocarbons that formed in the atmosphere and settled onto the ground. Imagine a desert made not of rock, but of dark, organic grains falling from the sky over geological time. That is Titan. The rivers and channels are equally unsettling. Some resemble drainage networks on Earth, where rainfall collects and flows downhill, but on Titan, the flowing liquid is methane or ethane. The bedrock may be water ice. The climate operates under alien chemistry. The result is a world that looks familiar until you understand what you are actually seeing. A river valley on Titan is not a river valley in the human sense. It is a channel carved by liquid natural gas through ice as hard as stone, under a sky filled with orange photochemical haze. That is why Titan feels so cinematic. It is not merely strange, it is almost wrong. It uses Earth-like processes with non-Earth materials. It has weather without warmth, seas without water, sand without rock, rain without comfort. It is a distorted echo of our own planet. And because of that, scientists cannot look away. The lakes and seas near Titan's poles remain some of the greatest discoveries of the Cassini mission. Before Cassini, scientists suspected Titan might have surface liquids, but there was no direct confirmation. Some early ideas even imagined a global ocean of hydrocarbons. Cassini showed something more complex. Titan did not have a single global sea. Instead, its liquids were concentrated mostly near the poles, especially in the north. This raised new questions. Why are the lakes mostly polar? How deep are they? How do they change with the seasons? What is their exact composition? Are they connected underground? Do they fill and drain through methane rainfall and subsurface channels? Cassini's radar helped measure some depths and surface characteristics, but much remains unknown. Titan's largest sea, Kraken Mare, is enormous, possibly hundreds of meters deep in places. Ligeia Mare is another vast body of liquid, with a surface so smooth in some observations that it appeared almost eerily calm. But Titan's seas are not peaceful in the way Earth's seas are peaceful. They are cold beyond imagination. They are made of hydrocarbons. Their waves, if present, may be small and slow, under Titan's lower gravity and dense atmosphere. Their shorelines may shift over seasonal cycles that last years, and beneath them may be sediments, dissolved gases, and chemical processes we have never observed directly. If a spacecraft ever floats on Titan's seas, it will not be sailing on water, it will be sailing on alien chemistry. The atmosphere of Titan is another mystery that Cassini transformed. Titan's air is mostly nitrogen, like Earth's. That similarity is striking, but Titan's atmosphere is much colder, denser, and chemically different. Methane plays the role that water vapor plays on Earth. evaporating, condensing, forming clouds, and falling as rain. But methane should not last forever in Titan's atmosphere. Sunlight breaks it apart over time. If nothing replenished it, Titan's atmospheric methane would eventually disappear, so something must be restoring it. That question remains unresolved. Methane could be released from the interior through cryovolcanic processes, where water-ammonia mixtures or other volatile-rich materials erupt instead of molten rock. It could be stored in subsurface reservoirs and released over time. It could cycle between surface liquids, atmosphere, and underground deposits. Cassini found hints, but not final answers. This is another reason Titan is so compelling. It is not just that methane exists there. It is that methane is part of an active system that must be maintained somehow. A world this cold should be simple. Titan is not. It has cycles, reservoirs, chemistry, weather, possibly internal exchange. It is a moon that behaves like an entire planet. When scientists speak about Titan's future exploration, they often sound different than they do with other worlds. Mars is the ancient desert. Europa is the hidden ocean. Enceladus is the geyser moon. But Titan is something else entirely. Titan is an atmosphere, a landscape, a chemistry lab, and an ocean world combined. That is why NASA selected Dragonfly, a future mission designed to fly through Titan's dense atmosphere using a rotorcraft lander. The idea sounds almost impossible at first. A flying machine on a moon of Saturn. But Titan is one of the best places in the solar system for powered flight. Its gravity is low and its atmosphere is thick. A rotorcraft can move from place to place, sampling different terrains, studying organic chemistry, and investigating whether Titan's environment could support prebiotic processes. Cassini and Huygens made Dragonfly possible. They showed that Titan has solid ground. They mapped regions of interest. They revealed atmospheric conditions. They proved that Titan is not only worth visiting, but worth exploring in depth. In a way, Cassini's final images were not an ending. They were a handoff. One mission fading into Saturn's clouds, while another waits to continue the story. But the phrase "final images" carries emotional weight, because Cassini's ending was irreversible. After the Titan flyby changed its orbit, Cassini entered the grand finale phase. It passed between Saturn and the rings again and again, exploring a region no spacecraft had ever entered. Each orbit brought new data, new risk, and a closer approach to the end. Titan had placed Cassini on that path. And on September 15, 2017, Cassini plunged into Saturn's atmosphere. It transmitted data as long as it could, fighting drag, heat, and increasing instability. Then the signal vanished. The spacecraft was gone, but the Titan data remained. The images remained. The maps remained. The radar swaths, atmospheric profiles, chemical measurements, and gravity data remained. Cassini died, but Titan became more real than ever. That is the strange power of space exploration. A machine can be destroyed, but the world it revealed continues to grow in human understanding. Before Cassini, Titan was an orange blur. After Cassini, it became a place with coastlines, weather, dunes, lakes, and hidden possibilities. A place where the surface is alien, but the processes feel hauntingly familiar. A place where the ingredients of life may gather, mix, freeze, fall, dissolve, and react over immense spans of time. A place that may never be alive, but still forces us to ask what life requires. The final images from Titan stunned scientists not because they showed something explosive or dramatic in the usual sense. There was no giant eruption, no sudden impact, no glowing ocean, no alien structure beneath the haze. What made them powerful was context. By the time Cassini looked at Titan for the last time, we understood enough to know how much remained hidden. Every image carried the weight of everything Cassini had discovered and everything it could never answer. Was Titan's methane cycle stable over geological time? Does the surface exchange material with the subsurface ocean? How complex is the organic chemistry in its dunes and plains? Could there be environments where water and organics interact long enough to create interesting chemistry? Are Titan's lakes connected by underground systems? Does cryovolcanism still occur? What is replenishing the methane? And most importantly, how far can chemistry go in a place like this? Titan is not a simple candidate for life. Its surface is far too cold for liquid water, but its chemistry is rich, and its interior may contain water. If material from the surface can reach the ocean, or if water from below can reach organic-rich layers above, then Titan becomes more than a frozen moon. It becomes a possible bridge between planetary chemistry and biology, not proof of life, not even evidence of life, but a world where the steps before life might be studied in a natural environment. That is why Titan matters. There is something deeply unsettling about Titan's silence. Mars looks dead, but open. Its surface is exposed, its rocks are visible, its scars can be photographed in daylight. Europa hides beneath ice, but its mystery is focused, an ocean below. Enceladus reveals itself through plumes, spraying its interior into space. Titan is different. Titan hides everything behind air. It does not let you see the ground easily. It makes you work for every detail. It takes visible light and turns it into a glowing orange wall. It forces spacecraft to use radar, infrared, patience, and repeated passes. And even then, it only gives fragments. A coastline here, a dune field there, a possible channel, a dark lake, a surface change, a cloud outbreak, a chemical signature. Titan never reveals the whole story at once. It makes every discovery feel like a partial confession. That is what Cassini's final images captured, not completion, but concealment. The moon remained veiled until the end. Even after 13 years of close observation, Titan still looked like it was keeping something back. And maybe it was. If you were standing on Titan, the world would feel almost impossible. The sky would be orange-brown and dim. The sun would appear as a weak glow behind haze, far smaller and fainter than it appears from Earth. Saturn might sometimes hang in the sky, but often hidden behind atmospheric layers. The cold would be lethal. The air pressure would be higher than Earth's, but the air itself would be unbreathable. The ground beneath you would be icy, mixed with organic material. Somewhere in the distance, dark dunes might stretch toward the horizon. In polar regions, liquid methane lakes could lie under the dim sky, smooth and black. It would be familiar enough to disturb you. There would be weather, there would be landscapes, there would be horizons, but everything would be chemically wrong. The rocks would be ice, the rain would be methane, the seas would be hydrocarbons, the sand would be organic particles. The warmth of the sun would barely matter. Titan is a world built from the wrong ingredients, but arranged in a way that reminds us of home. That is why it stays with scientists. Because Titan forces a question we are not fully prepared to answer. How Earth-like does a world need to be before it becomes important? Titan is not Earth-like in temperature, chemistry, or habitability at the surface, but it is Earth-like in process. It has cycles, flow, sedimentation, erosion, atmosphere, weather, surface liquids. It shows that planetary complexity does not require Earth conditions. It can emerge in deep cold, under alien skies, with methane instead of water. The final images from Titan were not the end of the story, because Titan is not finished in our imagination. It remains one of the most important destinations in the solar system, not because it promises easy answers, but because it asks better questions. It asks whether organic chemistry can become complex in environments far from the sun. It asks whether surface and interior systems can exchange material across an icy crust. It asks whether the building blocks of life can form, gather, and transform in places that look nothing like Earth. It asks whether habitability is a narrow condition or a spectrum, and it asks whether life, if it exists elsewhere, might begin in ways we would not immediately recognize. Cassini gave us the first true map of Titan. Huygens gave us the first view from its surface, but neither mission solved it. They revealed enough to prove that Titan is not just another moon. It is one of the strangest worlds humanity has ever seen. A moon larger than a planet, wrapped in air, filled with organic haze, carved by methane rivers, dotted with hydrocarbon seas, and possibly hiding an ocean beneath its frozen crust. That is not a simple place, that is a world. And perhaps that was the real message of Cassini's final images. Not that Titan had been understood, but that it had finally become impossible to ignore. In the end, Cassini's last look at Titan was not just a scientific observation, it was a reminder of how exploration changes reality. Before we arrive, a world is an idea, a point of light, a calculation, a prediction. Then the spacecraft gets close, and suddenly the idea becomes terrain. It becomes atmosphere, it becomes weather, it becomes chemistry, it becomes questions we did not know how to ask before. Titan was once only Saturn's largest moon. Now it is a place with seas, a place with storms, a place with organic material falling from the sky, a place where a probe once descended through alien clouds and landed on frozen ground, a place where future machines may fly. The final images were not dramatic because they showed everything. They were dramatic because they showed the last view before silence. the last close glance from the spacecraft that had spent years peeling back Titan's disguise. And still, after all that, the moon remained hidden, orange, cold, quiet, waiting. Some worlds reveal themselves with fire, like Io, some with oceans, like Europa, some with plumes, like Enceladus. Titan reveals itself through refusal. It hides behind haze, answers slowly, and turns every discovery into another mystery. That may be why the final images still matter, because they were not the closing frame of a finished story. They were the final frame of the first chapter, and somewhere beneath Titan's orange sky, beyond the dunes, beyond the methane seas, beneath the ice and the silence, the chemistry of another world continues in darkness, not waiting for us, not arranged for us, not shaped for our understanding, simply existing. A reminder that the solar system is not a collection of dead objects orbiting the sun. It is filled with worlds, some burning, some frozen, some hidden, and some, like Titan, are so strange that the closer we look, the less certain we become that Earth is the only place where nature learned how to become complex.